Okay, so now let us start the lecture. Okay, so and last time we had been starting to talk about the non-homogeneous equations. Okay, so the basic theory is basically saying we've been talking about very basics theory, right? So the theory says that if you would like to have a solution to the non-homogeneous equation, then it suffices to consider, right? So it suffices to consider the just one particular solution of the non-homogeneous equation, as well as the so-called complementary solution, right? So by complementary solution, it means a solution to the homogeneous equation, where you remove the non-homogeneous term, you set it to 0, you solve it, right? So so let's try to apply. Okay, so let's try to apply this whole theory to constant coefficient equations, right? So that means we've been talking about ay double prime plus by prime plus, right? So plus c of y is equal to 0. We know how to solve this equation, right? So this equation is being solved by considering ar squared plus br plus c is equal to 0, right? So as long as you have this, it means that you can see that there's going to be a solution y of t is c1 y1 of t plus c2 y2 of t. So that's kind of the way how you find a solution to the homogeneous constant coefficient equation. Now, what about the non-homogeneous case? Suppose ay double prime plus by prime plus cy is equal to g of t. There's a non-homogeneous term. Then you should start by considering ayc double prime plus byc prime plus cyc is equal to 0. This is what we call the complementary equation, right? So that's called the complementary equation, right? So now you solve this complementary equation, and the general solution here is going to be solution y of t is equal to c1. Okay, so it's equal to the complementary solution, right? So it's equal to the complementary solution. So that's equal to yc of t plus a capital Y of t, where this is just one particular solution of the non-homogeneous problem, right? So you just need to find one particular solution of the non-homogeneous problem. And the complementary solution has a further expansion. So c1y1 of t plus c2y2 of t, it is like the solution of the homogeneous equation, and then the plus capital Y of t. So the key point here is that we have been learning how to find y1, y2, let's say by characteristic equations, right? So this is the characteristic equation. So by characteristic equations, therefore, they were only left with how to find capital Y of t, which is just one particular solution of the non-homogeneous problem. So to this end, we're going to talk about today's two methods. They are very important for the rest of the semester, okay? So these are key methods that we're going to learn throughout the semester. Okay, so one very important method is so-called method of undetermined coefficients. Sometimes we call it, okay, so method of undetermined coefficients. Right, so sometimes we call it MUC, right? So, and the other method is the integrating factors. So the method of variation of constants, right? So the variation of parameters. Okay, so sometimes we say VP method, right? So V of V of P, right? So that's variation parameters. So that's kind of two methods we talk about throughout this two lectures. Okay, so let's talk about method of undetermined coefficients. What is a method of undetermined coefficient? Well, as we explained last time, it means that you're going to look at you're going to look at the g of t, and from the g of t, you determine the particular solution. So let's look at an example. Okay, so here's an example: y double prime minus 3y prime minus 4y is 3 times e power of 2t. Okay, so that's the y double prime minus 3y prime minus 4y is 3 times e power of 2t, right? So that's kind of the non-homogeneous equation, right? So how do we find a solution? Well, you should start from the complementary equation, minus 3y c prime minus 4 times yc is equal to 0. How do you solve this complementary equation? Well, you should start from r squared minus 3r minus 4 is 0. You want to solve for the r, so r minus r1 is equal to, so this is the same thing as r minus 4 multiplied by r plus 1 is 0, so r1 is equal to 4, r2 is equal to minus 1. So these are the two rules. And therefore, it means that the solution, the complementary solution, has to form c1 e to the power of 4t plus c2 e to the power of minus t. So that's kind of the complementary solution. You have the complementary solution. So that means the general solution y of t to this non-homogeneous problem should look like c1 e to the power of 4t plus c2 e to the power minus t. This is the complementary solution plus one particular solution of the problem. The question is, how do you find a particular solution? Is that good, right? How do you find particular solution? Well, so by method of undetermined coefficients, right? So by the method of undetermined coefficients, it means that you want to look at the right-hand side. Okay, so the non-homogeneous term in the right-hand side looks like e to the power of 2t. So it's an exponential function. It's an exponential to the power of 2t. And the left-hand side is the derivative. So let's say I want y capital Y double prime minus 3 capital Y prime minus 4 capital Y is equal to 3 times e power 2t. So find just one, right? So let's say just one. I just want to find one function such that its derivatives and itself recovered linearly combined together is an exponential function. So that's kind of a question about your sense of mathematics, right? So when do you have a function that when you take a derivative, you take another derivative, you combine together, is exponential? Well, you must realize that in calculus, right? So we have been learning a lot of derivatives, but there's only one derivative that's very special. That's the exponential function, because an exponential function, you take a derivative to the exponential function, you always have exponential function. Exponential function is a very robust knight against the attack from derivatives, right? So when derivative hits it, it kind of went back. It has a good shield, right? So it always fights back and gets itself. So that means that you must check, right? So that must check the y of this form. So it must be an exponential function, but it might be some coefficient. So let's say a, e, b, t. That's kind of exponential function. You take a derivative of that exponential function. So y prime of t, let's say a, b, e to the power of bt, and y double prime of t is equal to ab squared e to the power of bt. That's an exponential, is always being retained, right? But if you linearly combine them, it must look like 3 times e power 2t. So that means this kind of checking business do not have to involve that constant b, because the constant b must be equal to 2, because it was e power of 2t. Is that good, right? So that's kind of very important. It's not just an exponential function, but the exponent in the exponential function must inherit the original exponent. So that must be a 2. So this is a 2, there's a 2a, this is 4a, again a 2t. So that's, but a is a so-called undetermined coefficient. I mean, a is the so-called undetermined coefficient. A is the so-called undetermined coefficient. That's why the method is called the method of undetermined coefficients. Is a good family. A is the undetermined coefficient. So as long as you have this, you know that capital Y is a solution. So that means capital Y double prime minus 3 times Y prime minus 4 times Y. You kind of, from this calculation, it tells you that this is 4 times A, minus 3 times Y prime is 6 times A, and minus 4 times A is this 4 times Y, right? So, and then it's going to have e to the power of 2t. Is a good family, right? So that's kind of, this is going to be minus 6 e to the power of minus 6 of A e to the power of 2t is equal to what? It's equal to 3 e to the power of 2t. So that means a is equal to -1/2. So you find your a is a good family, right? So the undetermined coefficient is now determined, right? So that's determined by this a, and therefore you take the a back into the equation, so that capital Y is -1/2 e to the power of 2t. So that's one particular solution. As we said last time, it is sufficient to just find one particular solution. So that means once you have this solution, you know the general solution is C1 e to the power of 4t plus C2 e to the power of -t minus 1/2 e to the power of 2t. So that's it, right? So this is a typical way how you find a solution via the method of undetermined coefficients. Basically, it means that if the right-hand side is an exponential function, you should try an exponential function with the same exponent as the original exponential function, but with some unknown coefficients in front of exponentials. And your goal is to find those undetermined coefficients by plugging the solution back into the equation. Is it good for everybody? Okay, so that's kind of a very simple method that we can summarize on this idea here, right? So if the right-hand side is e power alpha t, then you should try e power alpha t, but with some constant that you never know. And you will know it by plugging this solution back into the equation, I mean the non-homogeneous equation, and you're going to find it. Is it good for everybody? Okay, so that's kind of a very simple example how it shows you how to find a particular solution. Remember, if the question is asking you to have a general solution, then you must combine your complementary solution with the particular solution. That's going to give you a general solution. Is that good for everybody? Okay, so that's a good procedure. So let us try to see, I mean, this method, how far this method can go. Okay, so there's a second example where you have the same left-hand side, but right-hand side is now 2 times sine t. Okay, so that's the same left-hand side, right? So the same left-hand side is going to be this, right? So that's going to be y double prime minus 3 times y prime minus 4 times y is 2 times sine. Okay, so 2 times sine of t, sine t. How do you find the solution? Well, you should again start from the complementary equation, right? So for y prime is c is 0, but we know already the complementary solution is c1 e to the power of 4t plus c2 e to the power minus t. So this is the thing that we already find in our previous example. Basically, the left-hand side is the same as the previous example. We just changed the right-hand side. But now the right-hand side is changed into a trigonometric function, right? How do you work on the trigonometric case? Well, you might work like in the same rationale as before, right? So let's say I want to try y of t is equal to a of sine t, right? So it's just because the sine, that's I want to try sine, but then you're going to see that y prime of t is going to be a cosinesis of t, and y double prime of t is minus a of sine t. So that sine and cosine are switching from each other. And if you linearly combine them, you're not going to just see sine, you're going to see cosine. Is that good for everybody? Okay, so that's the problem. And another question is, are you able to try, for example, so this is not a good trial, right? So let's say this is not a good trial, right? So it doesn't quite work. Now, then you're going to think about, for example, is it possible to try a sine 2t? Is that the case? Well, this is even far more unreasonable, because the 2 is going to break everything, because y prime of t is equal to 2a cosine 2t, and you're always going to have 2. And these 2's are not going to agree with the 1. So this is actually the same principle as the exponential case, that the argument sine the multiples of t should be the same as your guess, right? So that's like an exponent, but it's like the exponent is in the sine and cosine. So this is not a good choice either, right? So that's a bad way to guess. But remember, you are not going to find all these particular solutions. You only want to guess one of them. So you should look at sine t, right? So when sine t is taking derivative, it's cosine. When cosine is taking derivative, it's minus sine. So what does this mean? Well, it means that the sine and cosine have to fight together, right? So that it's not like exponential function. Exponential function is like a very single knight. He fights by himself against the attack from derivatives. But sine and cosine are like brothers, right? So they have to fight together. So when they expand, the derivative hits the sine is going to fade, right? So he's going to hide himself, but cosine is going to come out. And the same thing for cosine. When the derivative hits cosine is going to hide, and then sine is going to come out. So they all will fight together as a group, and they never decay, right? So that's kind of the thing. So what should try? We should try we should try A times sine t plus B times cosine t. So that's what we want to try, right? So the sine and cosine, remember, it is always shows up as a group, right? So as a pair, and you can never ignore any one of them, right? So if one appears, the other one must appear. So that's the story behind the sine and cosine. So that's kind of the thing. So you should try a linear combination of sine and cosine. And if that is the case, you just want to take further derivative. So y prime of t is a cosinuses of t minus b sine t, and y double prime of t is equal to minus a of sine t minus b of cosine t. So you're going to have this, right? So have this. Therefore, if you combine them, so y double prime minus 3y prime minus 4 times y, that's going to be what? That's going to be minus a times sine t minus b times cosine t, right? So, and minus 3 times y prime is a cosinuses of t minus b times sinuses of t, and minus 4 times y is a of sine t plus b times cosine t. So that's in the end, you have sine t. How many sine t do you have? There's a minus a, there's a b, right? There's minus 4a. So that's kind of minus 5a, right? So, and plus 3 times b. Remember, there's a minus 3 multiplied by minus b. This one multiplied by sine t, right? So, and then you have cosine t, right? So the cosine t is going to be, there's going to be 3b, 3a, right? So that's kind of minus 3a, right? Minus 3a, minus b, and minus 4b, so minus 5b cosine t is equal to 2 times sine t. Because 2 times sine t is a given here. But then we can say this is 0 times cosine t. Is that good, family? So you get some relations between a and b. It basically says 5a plus 3b is equal to 2, right? So 5a plus 3b is equal to 2. And minus 3a, okay, so minus 3a minus 5b is equal to 0. Is a good family, right? So is equal to 0. So that's going to give us, okay, so that's going to give us a solution, right? So that's going to give us a solution where a is equal to minus 5 over 17, b is 3 over 17. Okay, so that's kind of, so you can solve for it. A is minus 5 over 17, b is 3 over 17. Okay, so that's kind of the way how you find its solution. Okay, so minus 5a plus 3b, let me just double check. Okay, so minus 3a minus 5b. Okay, so that's kind of the solution. As long as you have this a and b, you get a particular solution. So particular solution, capital Y of t, is minus 5 over 17 of sine t plus 3 over 17 of cosine t. And therefore, the general solution, as we said, it was a combination of complementary and particular. So on an exam, maybe it's better to write it in this way. Okay, so you should write a capital Y and as well as small yc. Okay, so you write out both. Okay, so once you have this, you combine them, you're going to reach a solution. That's the form of c1 e to the power 4t plus c2 e to the power minus t minus 5 over 17 of sine t plus 3 over 17 of cosine t. That's a particular, that's the general solution. The good family. Okay, so that's kind of, this kind of give us a better idea of the undetermined coefficients, and such that we can summarize its rationale as follows. If you want to have a right-hand side is a sine t and cosine t, no matter what it is, it might be, we can treat it in general as a linear combination of sine and cosine. Suppose your right-hand side is a linear combination of sine and cosine. then you should try a linear combination of sine and cosine. It's just the point is that the factor beta within the sine and within the cosine in front of the t are going to be inherited because you're not going to use another beta. If it is sine beta, you should try sine beta and cosine beta. And if it is cosine beta, you should try sine beta and cosine beta. And if it's a linear combination of it, you should try the same thing. Okay, so that's kind of the beta is the same, but you're going to change A and B. And this is very general, particularly previously there was no cosine, but actually the V is equal to 0. So let's remember the sine and cosine always work in pairs, right? So they're brothers and they fight in pairs. They never separate from each other. Okay, so that's the sine and cosine business. Okay, so that's the second example that we have been talking about in this lecture. So let's look at a third example is the following. So can you find the general solution y double prime minus 4 times y minus 3 times y, right? So let's say, okay, so it's 3 times y prime, right? So minus 4 times y, all right? So that one is going to be equal to, 14 squared minus 1. 40 squared is 1. Okay, so I want to find a solution of this problem. Now, again, the complementary solution never changes. So that yc for yc is 0, and complementary solution, we already found its solution, right? So it's a c1 e to the power of 40, right? So all these complementary solutions are the same. So you don't have to worry about these complementary solutions. Now, how do you find a particular solution? Well, here, the right-hand side becomes a polynomial. Right, so the left-hand side, so they want to find a y of t, such that y double prime minus 3y prime minus 4y is equal to 4t squared minus 1. So can you find at least such y of t? Well, to solve this problem, must realize that it is a linear combination of some derivatives. Right, it's a linear combination of some derivative. And this linear combination of these derivatives results in a polynomial. So for what function you learn in calculus, that if you take a derivative of that function, you're going to reach a polynomial. Well, the only possibility is the polynomial. So only polynomials are taken derivatives are going to be polynomials. Is that good, right? So now we're going to try a polynomial. So we try a polynomial. So a polynomial takes the form a0 plus a1, right? So of t plus a2 of t squared plus dot 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 plus an t to the power of n. Is that good? That's a polynomial. Now, what kind of polynomial you should try? Well, remember here is a 4 times y here. So if n, let's say n is equal to 3, you're not going to reach a second order polynomial, right? So polynomials have a hierarchical structure. Only let's say a higher order polynomial, take a derivative, you're going to shrink just to one order. And if the left-hand side has this polynomial, then it must inherit the degree of this polynomial. So that gives us the more realistic conjecture that it should look like a plus bt plus ct squared, and you never increase. Is it possible to just try a plus bt? Well, that's not good either, because you're going to reach, when you take derivatives, you only reach the polynomials of a lower order. And so the highest order of the derivative on the left-hand side will be first order. It will never be a second order polynomial. So you should try exactly the order of the polynomial is exactly equal to the right-hand side. The right-hand side is a second order polynomial. Then you should try a second order polynomial. You don't try a first order polynomial. And but neither you try a third order polynomial. Your order of the polynomial should be exactly equal to the one for the right-hand side. Is that good for everybody? Okay, so that's kind of the polynomials. So let's look at this polynomial. Okay, so we're going to see y double prime minus 3 times y prime minus 4 times y. Okay, so that polynomial is equal to what? Well, we can see that if 4 times y is 80, so that's kind of minus 4 times a plus bt plus ct squared. So that's kind of this is the polynomial. Now it's minus 3, and then you take a derivative here. So that's b plus 2ct. And then you take a second derivative here. That's 2c. Is a good tablet, right? So that you get all these derivatives just by calculating these derivatives. So that you should combine all of them, right? So that's minus 4ct squared, and then there's a b. So the b is going to be minus 4b, right? 4b plus 6 times c of t, right? And then there is okay. So there is a constant term here. So the constant term is 2c minus 3b minus 4 times 8. Make sure I make everything correct. Is that good, tablet, right? So you get this, right? So now this one is going to be equal to the polynomial that you're looking for. Is a 4t squared minus 1. So that kind of gives you the relation. At least the c is equal to minus 1. C is already found, right? So c is equal to minus 1, right? So let me double check. Okay, so I have ABCs in a 8t squared plus, okay, so the ABCs are different from what I have here, but it's completely fine. Okay, so c is equal to minus 1. And then as you're going to see that it's 4b. Okay, so 4b plus 6c is 0, so that b is equal to what? C is minus 1. So 3 over 2, right? So b is equal to 3 over 2. Okay, so this is the b is the b. Okay, so and then you want to find a. You're going to see that 2c minus 3b minus 4a is equal to minus 1. And this is going to tell you c is minus 1, so minus 2, right? So minus 3b is 9 over 2 minus 4 times a is minus 1. So that 4 times a is actually equal to minus 1 minus 9 over 2. So it's minus 2, so that's 11. So that a is equal to minus 11 over 8. So you find your constants ABC, right? As long as you have the constant ABC, this minus 11 over 8 plus BT. Okay, so BT is 3 over 2 of T plus CT squared. CT squared is a minus, right? So that's a minus T squared, and therefore it's you get this. This is your particular solution. And you combine these two parts. Okay, so I won't do all of this. You combine these two parts, you're going to get your particular your general solution. So that's kind of a general principle for polynomials, right? So for polynomials, but we can summarize as follows. So if you have a polynomial function as your right-hand side, right? So if the right-hand side is a polynomial function of a certain form of order n, then you should try a polynomial function of the same order, right? So you will never decrease the order of your polynomial. If the right-hand side is a polynomial of order n, then you should try a polynomial of order n, but with the different coefficients that you would like to determine. So that's kind of the key point, is that you inherit the order of this polynomial. So that's so far we have seen 3 different examples. We have seen, for first example is for exponential function. We say that if you try an exponential function, then you should try your right-hand side is an exponential function, then you should try an exponential function of the same order, of the same exponent, right? Exponent means that there's this coefficient in front of the t, right? So in the exponent. So you should try the same function with the same exponent, but with a different, change the coefficients, right? And you determine those coefficients. That's why this method is called the method of undetermined coefficients. Okay, so and then this we tried the sine and cosine, right? So trigonometric function, and unlike exponential function, trigonometric function always appear in pairs, right? So that means if you have sine or cosine or maybe both, then you should always try both, right? So you are never going to miss any one of them in this either one of them in this pair, right? So it's sine and cosine should appear together. Okay, so that's about a trigonometric function. Then we tried another form, which is the polynomial function, and we said that if you have a polynomial, you should try the same order polynomial, right? So you never decrease the order of your polynomial. So that's kind of the 3 conclusions. Now let's look at one more example. Okay, so let's look at one more. more flexible and synthetic example. Here it says that y double prime minus 3 times y prime minus 4 times y is equal to, here, is 2 times e power minus t. Okay, suppose, so this looks like an example that we should be able to solve because it's the right-hand side is just an exponential function, right? And the right-hand side is just an exponential function. Shall we try exponential? So basically yc double prime minus 3 times yc prime minus 4 times yc, right? So it's equal to 0, and that's going to give you a complementary solution. Yc is equal to c1 e to the power of 4t plus c2 e to the power minus t. Is it good for everybody? Okay, so now we want to try a function capital Y of t. Of course, you want to try a times e to the power minus t, right? So because the right-hand side, as we said in basic principle, right? So that's you should try a polynomial of the same, an exponential function with the same exponent. Now you want to set y prime of t, right? So y prime is equal to minus a e power minus t. Y double prime of t is equal to a times e power minus t. You combine them, that's going to give you y double prime minus 3y prime minus 4 times y is equal to what? Well, it's equal to a minus 3 times y prime is minus 3 times a, right? So minus 3 times a, and then plus minus 4 times a, right? The whole thing here multiplied by e power minus t. This is going to be 0 because a minus 3 times minus 3, so 4a minus 4, here is the y is actually equal to a. Right, so y is actually equal to a. It's going to be 0, and if it's 0, it doesn't give you anything. Is it good, right? So that it never gives you 2 times e power minus t. So it looks like very surprising. Why is that the case? Why is that the case? Well, it's kind of a special, right? So there's actually a trap here because we said that if the right-hand side is exponential function, you should try exponential function. But this exponential function agrees with part of the complementary solution. Remember, what is a complementary solution? Complementary solution means that no matter how you choose C1, C2, you put it on the left-hand side of this equation, you must end up with 0. That's why we say it's a complementary solution. Is that good for everybody, right? So you must end up with 0. So that means if exponential function, you should try exponential function. That's a general principle, but unfortunately, if the exponential function agrees with part of the complementary, it might be e power 4t. Is also okay. If it agrees with part of the complementary solution, then you cannot use this exponential function as your solution. It doesn't quite work. Is that good for everybody? Okay, so that's kind of the situation is that if the right-hand side agrees with part of the complementary solution, right? So if the right-hand side agrees with part of the complementary solution, you're lacking solutions. And what you're going to do if you're lacking solutions? If you're lacking solutions, you're kind of in a scarcity. And we have been telling you about one very important principle. Whenever you feel scarcity, that's what we call the golden principle, right? So that's what we call the golden principle, right? So that's what we call the golden principle, right? So that's, let me use this color, okay? So this one, okay? So that's what we call the golden principle. Right, so this is a very important principle that we have encountered previously, right? So the golden principle. What is the golden principle? The principle says that you're going to try y of t. Whenever you're lacking solutions, you're going to enter a solution there, right? So enter a t there to create another solution. If this also agrees with part of the complementary, you're going to insert another t. So this is very, very flexible, okay? So this is just an example that shows you the particular case. Maybe the right-hand side is cosine, but it doesn't matter if it has, remember, it has complex roots. Then you have sine and cosine. If the cosine also agrees, you should also insert t. So one should practice. Okay, so you should practice a lot of examples. But here for this one, it suffices to say that we're going to insert 1t because 1t then it already distinguishes from the complementary solution. So you try this solution. So you want to try this solution so that y is equal to a times t power t, right? So a times t power minus t. And therefore, your y prime is minus a times t e power minus t, right? So you take a minus sign here. Then is plus a times e power minus t. Am I right? So you take a derivative. And then the second derivative is going to be, you're going to take another derivative here. So that's a times t power minus t. And then it's you're going to take a derivative here. So that's minus a times e power minus t. And plus the derivative of this one is minus a times e power minus t. So that's in total, you're going to have a t e power minus t minus 2a times e power minus t. It's a good family, right? So you get all this, both of these derivatives here. Okay, so both of this derivative here. Okay, so as long as you have this, you can combine them, all right? So you can combine them. So that's y double prime minus 3 times, okay, so minus 3 times y prime minus 4 times y is equal to what? Well, it's equal to a t e power minus t minus 2 times a e power minus t. So that's y double prime minus 3 times y prime. Okay, so 3 times y prime is 3 times minus a t e power minus t plus a e power minus t, 3 times y prime, right? So, and minus 4 times a t e power minus t. So you can kind of collect the terms, right? So let's first collect e power minus t. So you're going to have minus 2a plus 3a, and that's it, right? So that's it, right? So that's minus 5 times a e power minus t, am I right? What about e power t power minus t? So there must be a constant t e power minus t here. What will be this constant? Anybody has idea? Well, remember, you want the right-hand side, right? So you want the right-hand side to be 2 e power minus t. So 2 e power minus t. Right, so you want the right-hand side to be 2 e power minus t. So the mysterious thing here is that if the calculation is all correct, then you must reach 0 here, because you never have such a term t e power minus t. In case that your calculation is correct, but it might happen that your calculation has errors. So we have to double check, right? So we have to double check. And how do we double check this? Well, it's a very easy business, because here you're going to have 1a. There's going to be an a, and then there's a minus, t e power minus t. Okay, so let's see. There is a plus 3a, because this is 3a. And then there is a minus 4a. So indeed, it is 0, like what we predicted. Is that good, family? Okay, so that's kind of, this is a nice tip for your exams. If you're short of time, then you just try 0, because the right-hand side doesn't have this term. But maybe your calculation is wrong, so you have a risk. When you do this, you are exposed to a risk that your calculation is wrong and you never detect it. So the good idea is that you calculate faithfully, and you double check that this is nothing. Is a good family? Okay, so but at least it tells you that a is equal to minus 2 over 5, because you just identify this 5 over this 2, you get a. As long as you get a, you get y of t is equal to minus 2 over 5 t times e power minus t, and then you have the general solution. The general solution is going to be y of t to this equation is going to be c1 e to the power of 4t plus c2 e to the power minus t plus minus 2 to the 5 t times e to the power minus t. Is that good? Right? So that's kind of the thing, right? So minus t. Okay, so that's kind of the thing. Okay, so this kind of a very general principle is going to be stated as follows. If the initial assumption of capital Y of t is overlapped with part of the complementary solution small y, then we keep multiplying the initial guess of your solution by t until it is not overlapped with any part of the complementary solution. So this is how you deal with this business. Okay, so if the initial assumption of capital Y of t overlap with part of the complementary solution, then you keep multiplying and t until it's not overlapped. And this is very, very general. Okay, so it doesn't really, I mean, this one is only an example where you have an exponential. Maybe it's a sine and cosine. It also works, right? So it also works because if your sine and cosine, then you have complex roots in the complementary equation, you're going to have sine. So it might happen you work with t sine, t cosine. And what happens if these both are t? So they already, the complementary solution has a double root. You have already a t here, then you should try t squared. You just do not hesitate to multiply by t because this is our golden principle. Whenever you are lacking solutions, you're going to add a t, right? So if you're lacking solutions more, you add more t until you're not lacking solutions. So that's kind of the idea behind this situation. Okay, so behind this, so you can see that the whole theory is quite empirical, and it has there's a lot of possibilities to explore here. Okay, so there's a lot of possibilities to explore here. Okay, so let's try this one more example. Okay, so there's one more example I'd like to look at. It's a y double prime minus 3 times y prime minus 4 times y. So again, the right-hand side is now a combination. So 3 times e power 2t, right? So e power 2t plus this 2 times of sine t. So I want to try this. Okay, so what kind of solution we should try? Well, here is it's like a combination of what we have known before, right? We know what to do with sine and cosine. We know what to do with exponential. So what should we do with a linear combination of the two? That's the problem, right? So what should we do with a linear combination of the two? Well, imagine that you find one solution. Let's say y1 double prime, right? So you find one solution, minus 3 times y1 prime minus 4 times y1 is equal to 3 times e power 2t. Suppose you find one particular solution, right? So let me say particular solution. Okay, so I will try particular solutions. So that means okay, so I will try particular solution. So y1 3 times y1 4 times y1, right? So I will try particular solutions, and then you suppose you tried another particular solution. Let's say 3 times y2 prime minus 4 times y2 is 2 times sine t. Then you can see that it suffices to combine them. So that y1 plus y2 double prime minus 3 times y1 plus y2 prime minus 4 times y1 plus y2 will be equal to what you want to have. So that's a 3 times e power 2t plus 2 times sine t. So that's what we already have. If you have linear combinations, is a good fabric, right? So this is in algorithms, right? So if some of you are taking classes in algorithms, this is called divide and conquer. Right, so you divide your task into several different tasks, and you conquer each task, and finally you combine them. So that's the principle is called divide and conquer. Is a good favorite. Okay, so the principle is divide and conquer. So you should apply this divide and conquer idea, and divide and conquer already tells us that this y1 is already found. Y1 is found in our first example, right? So in our first example, it's a minus 1/2 e power 2t. That's y1. And the y2 is already also found. It's found in our second example, right? So it's a minus 5 over 17 plus 3 over 17, minus 5 over 17 e power sine t, right? So minus 5 over 17 of sine t, right? So minus 5 over 17 of sine t plus this 3 over 17, right? So plus 3 over 17 of cosine t. That's y2. So therefore, in order to obtain general solution, it suffices to try the linear combination minus 1/2 of e power of 2t and minus 5 over 17 of sinuses of t plus 3 over 17 of cosinuses of t. Right? So you can try both. You can try a combination of these two. So that's just an idea, which we're going to call it the divide and conquer. Okay, so that's an idea that we're going to call it the divide and conquer. It says that if you have a linear combination of different types of the right-hand side functions, okay, you have a linear combination of the different parts of the right-hand side function, then you should work out the particular solution for each term in the linear combination, and you combine, right? So you work for the particular solution for each term in the linear combination, and then you combine all of them, you obtain your solution. So that's kind of the idea, is what we call it the divide and conquer, right? So that divide and conquer. So the divide and conquer is actually have many, a lot of possibilities to explore. Okay, so it's a lot of possibilities to explore. So here's a nice example. Okay, so but for the previous example, one last thing is that this is only a particular solution. If you want general solution, you should try C1. Remember, do you remember the solution? E to the power 4t, C2 e to the power minus t, and minus 1/2 e to the power 2t, minus 5/17 sinuses of t, plus 3/17 cosinuses of t. That would be a solution. Is that good for everybody? Okay, so that's kind of the thing. Okay, so here's one more example that's about the divide and conquer, but it's in the product form. So that's the solution is going to have the form y double prime minus 3y prime minus 4 times y. The right hand side is going to be a product minus 8e power of t multiplied by cosinuses of 2t. Cosinuses of 2t. So what kind of solution you should try? Well, this is a product. So the product, you should also use the divide and conquer, but in terms of product. Is that good for everybody? Okay, in terms of product. So that's what kind of solution you should try. Well, you should try yt in terms of product. So that means it should be a e power t, because the e power t is going to be your solution if you just have e power t. But it's a divide and conquer in terms of product. So it's a product of the two. So that means there's a b cosinuses of b of, okay, so I should say b of sine, right? So sine and cosine are appear together. So sine of 2t plus c of cosinuses of 2t, because the sine and cosine appear together. Is it good for everybody? Okay, so, but it doesn't matter. We can just say, and this is a multiplied by b. So I will just say, okay, so I will just say, that's equivalent to saying that this is a e power t multiplied by sine 2t plus b e power t multiplied by cosine 2t. That's going to be a solution. Is that good for everybody? Right? So that's going to be your solution. Okay, so that's going to be your solution. So that's the only task is determine a and b. Okay, so the only task left is to determine a and b. But this is a very complicated process. Okay, so maybe I will not go much deeper into this calculation. It's kind of very sophisticated calculation, but it can show you that this is a e power t cosine 2t, b power t sine 2t. You keep taking derivatives faithfully. It will take a lot of calculations, but tedious. Okay, so it's simple and tedious calculations. And you combine all of them, it's even more simple and tedious calculations. But in the end, you're going to reach the relation that minus 10 times a minus 2 times b is minus 8 is 2a. So you're going to solve for a and b, you get your solution. So that's kind of another way to do the divide and conquer. It's just with very complicated calculations. Usually this is not involved. It's not be on your exams. You won't see these kind of complicated problems. Okay, so but it's just to show you an example that you're still able to find a's and b's. Okay, so by divide and conquer, if the right hand side is a product form, then you should divide and conquer in terms of product form, and you get your solution. Okay, so that's a way of how you find it. So that's our conclusion is that if the right hand side is an exponential multiplied by sine or cosine, you should try an exponential multiplied by both sine and cosine. And the more general conclusion says that if you have a product of the 3 types of right-hand side, that means that it's either a polynomial, an exponential, or sine, cosine, then you should try product of the corresponding solutions assumed in the examples. Is that good family? Okay, so that's a method of undetermined coefficients. Basically takes the form of a right-hand side of a particular forms. It might be exponential, it might be sine and cosine, it might be polynomial, and you try the corresponding ones. And you have to deal with the special cases. For example, if there are multiple roots, right? So your solution agrees with part of the complementary, then you should use the golden principle. You should multiply by t. And in some cases, the right-hand side might not be single sine, cosine, this single form of these equations, but it might be complicated in terms of product or sums. Then you should use the principle of divide and conquer. You divide your solution into several different parts and combine them. So that's kind of the thing about method of undetermined coefficients, where I have a lot of examples here left for you to practice. Okay, so that's you must practice method of undetermined coefficients until you get familiar with this method. Okay, so this is a very important part of our lectures and will be tested on the exams. Okay, so that's kind of very important. Okay, so that's all I want to say for the method of undetermined coefficients. Let us come back in the next lecture, and I'll talk another method called the method of variation of parameters or variation of constants. Okay, so let's come back to our lecture in the next lecture, and we will continue. Okay, so see you in the next lecture.